All right, so it's go time. Um, let's go. So, welcome everybody. My name is Wilbert Roberto Hernandez. I'm the Vice President of Students for the Exploration and Development of Space at the University of Puerto Rico at Mayagüez. And today I have the pleasure of hosting this special talk, special space talk by NASA's JPL manufacturing engineer, Leonard Ortiz. He will be talking about his journey to Mars. So without further ado, I'll leave it to Leonard to present his slides.
Hey, Wilbert, en la Universidad de Puerto Rico, Mayagüez. My name is Leonard Ortiz, so me pueden llamar Leo o Leonardo, como ustedes quieran. I work at NASA's Jet Propulsion Laboratory, JPL, in Pasadena, California. And as a manufacturing engineer, as an ingeniero de fabricación. So what I do at JPL is I essentially help build space parts. So I help make the parts that go into space and also the parts we use for testing and operations here on Earth before we send them to space. So it's been a really exciting time, especially with we just launched the Perseverance rover in July, and which will be landing soon. So I wanted to come here and thanks to Wilbert for the invitation, but I wanted to kind of talk about like my journey as well as the Perseverance rover. So yeah, so my journey kind of began. So my parents are actually from Mexico, and they migrated here in the early 20s. But I was born here in Southern California, and have been here since then. I went to pretty much all. So I went to school, and I would say Spanish was my first language up until I went to preschool, kindergarten, and where I picked up English and all that. And then it wasn't until actually till the end of high school that I got interested in space exploration. A lot of people kind of have the story of, they look up at the stars and when they're younger, and then they kind of have an interest in space and want to become an astronaut and all that. I didn't. I actually started a little bit after high school when I first heard of the Curiosity rover, which launched in 2011, landed in 2012. And so since then, I kind of went on a path to kind of study engineering and especially in space exploration. To me, it was kind of more of a challenge. I saw it as what's the hardest thing humans can do, which is space exploration. And so that kind of led me into a path into trying to work at NASA. And actually, when I was in high school, I actually didn't even know that we had a NASA facility here in California. I always thought that NASA was either in Texas or in Florida. And then when I found out that JPL was in Pasadena, it's kind of, I was like, whoa, it got me out of surprise. And that kind of made me kind of work harder and try to get in and work at NASA. So I eventually went and studied at California University State Fullerton. So in Fullerton, that's when I studied mechanical engineering. And then so later in 2015 is when I joined a rover competition called the University Rover Challenge that is held by the Mars Society every year in Utah. So in 2015, I joined the team's called Titan Rover in Fullerton. And so since then, that kind of helped me open my eyes of like, I think I could do this. I think engineering and building rovers isn't that hard. The hard part is sending it to Mars and operating it on the surface of Mars. So 2015, I met someone that was on the team, and she was interning at JPL. And that kind of gave me the inspiration and motivation to also follow that dream, that passion, that goal. And so I just started applying and slowly began my journey into working at JPL. But it took me a while. I didn't get hired on till 2018. So I've only been at JPL for 2 years now as a manufacturing engineer. But yeah, it's kind of been a journey to get there. I am a first generation college graduate, and it's been a challenge, but it's also been really rewarding. And yeah, I'm just kind of here to share that story and make sure that, like, if you have dreams out there that you want to follow, you want to pursue, whatever passions you have, just keep going, and like, don't let anybody tell you that you can't. And always just the main thing also is get a mentor, get someone that that maybe can help you get to that goal even faster, or someone that you can learn from. And that's kind of what I did. So I met my friend, and yeah, so now we're here. Bienvenidos. So then, yeah, so that's a little bit about me. But what I really wanted to talk to you about is the Perseverance rover. So we'll get right into the slides right here. Let's see. Let me know if you can see this. I think we're good. So yeah, so my name is Leonard Ortiz, manufacturing engineer at JPL, Ingenuity de Fabricación.
I don't think we're seeing your slides.
Oh no, okay. I think I gotta. Let's see. Let's go. Here we go.
Yep, now we are seeing it.
Yeah, that's what I forgot to do. Okay. Yeah, so manufacturing engineer at JPL. So first wanted to kind of talk to you about the previous rover missions that we've had. At the bottom left corner, you can see the small little microwave sized rover. That one is from the Pathfinder missions. That was Sojourner rover. So this rover was actually one of the first kind of designs of trying to test to see if we can communicate with a moving system on the surface of Mars. As you can see on top of it is solar powered. So that's kind of how it was powered. And its main mission was just to be able to communicate back to Earth. And once it did that, it was a success. So that was kind of like the precursor of design to be able to build what is on the left side, which is the MER rovers, which is the MER, Mars Exploration Rovers, which we built two of, the Spirit and Opportunity rovers. These were twin rovers that landed on the surface in 2004. And these rovers were also solar powered, but this one had the camera that you see on top, kind of the head of it, and then also had a robotic arm in the front of it. So this kind of led into a path of building bigger and better, which you can see on the right side, which is the Curiosity rover. And the Curiosity rover was kind of like was the biggest rover ever built, and now is the kind of what we designed the Perseverance rover after. That's what you kind of see if you see the Mars Perseverance rover. You see like, oh, don't we already have that on Mars? Well, yeah, kind of. But the Perseverance rover has a lot of new instruments that will help us kind of search and find signs of life. So that's why we're kind of going back to Mars. And here I have a video for you guys to see of how the Mars 2020 rover was built. And then one thing I want to emphasize is the kind of the importance of teamwork. As you can see, the Mars Perseverance rover is a huge, huge mission. And this mission kind of includes so many different types of people, so many backgrounds, from engineers, scientists, even business administrations, artists, just so many people. As you can see right here, the wheel is being fabricated. So this is kind of like what I do. We build to print, so we get a design and a print of what the engineers want, and we help them kind of assess and see if that can actually be made. Like what materials are needed, the fabrication time, the tools that you need to fabricate parts, and then we also go through the full process from if it needs to get painted, if it needs to get anodized, and also qualified to fly. Which that's kind of like one of the hardest things that we deal with is trying to get parts to be qualified to fly, which we kind of battle sometimes with our quality assurances engineers, but in the end, we're a team. That's why I kind of want to emphasize the importance of teamwork. Here's a cool chart that has the previous rovers and also landers. We did just land InSight in 2018, which was to study the core of Mars. But the rovers are kind of like the what we're actually looking for, signs of life. So you see the Mars 2020 rover in the front, and right before it is actually the ExoMars rover, which is from the European Space Agency, which actually did not launch in 2020. I think now they have a target date of 2022. I think that was a COVID kind of got in the way, but that's okay. And so before that, 2011, that's Curiosity rover, launched 2011, landed 2012, and then Mars exploration rovers, as you can see, 2003. And before that, the Sojourner, which is 1997, which is one of the first rovers we landed on Mars. And so we have the current timeline right now. We just launched the Perseverance rover in July 30th, 2020, and we'll be landing soon in February 18th, 2021. So right now we're in the cruise stage, heading to Mars. And then if you want to kind of follow along, you can go to, I think I'll put the website after, so you can see where it's at exactly, and you can kind of follow along the trajectory as well as the speed of which is going relative to the sun. And it's a pretty cool little image that you can see of the Perseverance rover in cruise stage. So why are we going back to Mars? Sometimes people just ask, like, like we've been there before, why again? Well, this time we want to find out if Mars ever had life. So the main goal and mission of the Perseverance rover is to find microbial life and see if there's any signs of ancient life. Which we have 7 cool new instruments that will help us do that. And the Perseverance rover is also going to be the first mission that will be able to collect samples and bring them back to Earth, which is probably one of the coolest things that I guess one of our rovers has been able to do. We're going to be able to collect samples for a future mission, and those future missions are kind of, right now, they're being proposed and designed. So if hopefully in the future, maybe, one of you guys or gals can be part of the mission that helps bring back samples. That would be pretty cool. So there's 4 main objectives for the Perseverance rover, to study geology, astrobiology, and the sample caching. Sample caching is what we'll be using to return the samples back to Earth, and also prepare humans for Mars. One of the biggest things is once we've studied Mars as much as possible, like what's the next step? Well, kind of how we did with the moon. We went to the moon. Now we're kind of planning to send humans to Mars, but we have barely scratched the surface of understanding on how to not just get humans to Mars, but also survive on the surface of Mars and do some operations there. And we'll be landing in Jezero Crater, which was once known as, or it's known as the Ancient Delta. We think at one point it was covered with water, so it was a whole riverbed. And so at Jezero Crater, as you can see, there's those kind of flow marks is of water flowing from what we believe was either the ice caps melting or another body of water that flowed this water into here. And so we're going to be trying to land there, as this has been kind of the best spot to land. There was there's 2 other landing sites that were proposed at first, but the scientists got together and they, after many weeks and months of deliberation and getting together and kind of trying to see which one would be the best one, Jezero Crater ended up being the one that got picked for its location, and also the water that we think was once there. So I also wanted to kind of go through and see the differences between the Curiosity and Perseverance rover. As you can see, they kind of look similar, kind of like how I mentioned, but from afar you can kind of tell which one's which by looking at the wheels. So the wheels, actually, we improved these because prior the chevron design on the Curiosity rover, those those linear lines right there, that actually caused an issue right in the middle of where the lines connect. That caused a stress point, and over time the Curiosity wheels actually began to crack. And so right now, there is no AAA on Mars, so there's no way of fixing these wheels. So what we had to do is kind of go back to the drawing board and figure out a new design for the wheels. And so now we have what's on the right side, the Perseverance rover wheels, which we call these treads with their Gausers. And so we went through many iterations of testing the width, thickness, and the depth of these new treads. And so we ended up with these, and it has twice as many treads as the Curiosity rover, which is I believe at 48 of these Gausers. And yeah, we also increased the width. It's a little bit more narrow because we didn't need the wheels to be so so wide, and also the titanium spokes inside. Those are also, we increased those to make them a little stronger. So the titanium spokes are that are in the middle are kind of create and help it with the suspension. So it's like most cars, you have the suspension kind of in the inside or in the back of by the wheel, which these actually are in the wheel. Because again, the Mars rover is a little different than actual building a car. So some of the other differences between the Mars Perseverance rover and Curiosity rover, as I said, the wheels. We also have a lot new cameras. The Curiosity rover had about 17 cameras. Now we have 23, and most are in color. So we'll be able to actually take these images straight from the camera database and see the images in color. Right now, we take the images and we kind of make them from black and white into color. So this will be really, really cool to be able to see these images come back to Earth once we land. We also have the turret, which holds about 2 new, really, really cool new instruments that I'll get into in a bit, and as well as the sample caching system that will be used to collect the samples and bring them back to Earth. So as I mentioned, the 23 cameras, there's 9 engineering cameras, 7 science cameras, and then 7 entry, descent, and landing cameras. So the entry, descent, and landing that's the phase in which we begin to ascend and lower, bring the rover into the atmosphere and descend and land the actual rover on the surface of Mars. So we have a couple of cameras that will capture that phase, which one will be pointing back at the parachute, and then we'll have a video camera pointing down at Mars as we land. So we'll actually be able to see that full entry, descent, landing phase using that camera. And there's actually going to be a microphone built into the cruise stage. So we'll actually be able to listen as we land on the surface of Mars, which is going to be really, really cool. I don't think we've ever been able to listen from the point of view of the rover landing on the surface of Mars. So it's going to be really interesting and really exciting to see that. So we have the SuperCam and MassCam, which are the head of the rover. The SuperCam is kind of the instrument that helps us analyze and the chemical composition by shooting a laser at rocks. And our MassCam Z, we actually had a MassCam on the Curiosity rover, but these ones actually have full range of zoom, and these will give you a depth of field of how far things are. So it will kind of help you visualize and see like as if you were there on Mars, giving it the spatial 3D effects, which will be really cool to see. So as mentioned, the SuperCam is what we'll be using to study the rocks these will actually be shooting the lasers at the rocks and analyzing them. So with the super cam and the mass cam, that will kind of guide us to the rocks that we want to analyze a little bit better to eventually be able to use the instruments on the turrets, which the Sherlock and Pixel, which I'll get to in a bit. But these are kind of like our navigation cameras that we use to locate, detect rocks. And then once we are kind of happy to proceed, then we move forward. So we also have RIMFAX, which is the radar imager for, let's see, for Mars subsurface experiments. This will help us see on the subsurface of Mars, and we'll be able to not just detect kind of like what's there, but it will be able to see some rock, ice, water, and see if there's any salt water underneath. Kind of this also is another tool to help us see and detect where we want to go and if that's a location that we want to actually dig under. So here we have the Sherlock and Pixel instruments on the turret of the Mars rover. So these tools, it's actually really, really cool. These are the ones that will kind of help us study the organic, chemical, and compounds and elements of rocks. So these ones we have located an area that we want to, like study better. We'll use these instruments to look inside the, like the rocks and the elements. Up to, these can actually see like up to kind of like a grain of salt and study these a little further. On the next image, I'll show you guys. So right here, you can see some of the things that we kind of plan to see using the Sherlock and Pixel instruments. So Sherlock is kind of, it stands for scanning habitable environments using Raman, luminescence, and organic for organic chemicals. It's kind of a long acronym, but essentially Sherlock is kind of like named after Sherlock the investigator. So essentially what we have here is our investigator to investigate rocks to see if we could find any ancient microbial life. And that's kind of what we're really after. Using Sherlock and Pixel, these two instruments will kind of help us answer that hard dying question, like is there any signs of ancient life, and can we detect it here? The next one is one of the kind of, I would say there are, so when we talk about Perseverance rover, we kind of see like, oh, it's a one rover, one giant robot, but realistically it's kind of a three-part robot. So you have the arm, which is its own acting kind of system, and then you also have the sample caching system, which this also acts like as its own robot. It's a whole entire system inside. I'll show you a video in a bit that kind of shows the whole operation of collecting a sample, putting it into the sample caching system, analyzing the sample, and then eventually kind of dropping it off in a certain location. But so this sample caching system essentially is where we move the rock sample from the turret into here, and then inside there's actually locations where the soil samples will be analyzed and will also be stored, and then we'll be able to drop those off at designated locations. And yeah, this is kind of like one of the craziest things, because once we are able to successfully drop off these soil samples, we'll we'll be coming back with another rover and lander, and hopefully a Mars ascent vehicle. It's called MAV, to return these samples back to Earth. And if you ever get a chance to look up Mars sample return, there's a video online that you can see of this whole, I guess, proposed mission, and it's pretty nuts. And if we could accomplish that and successfully do it, it's going to be really, really, really cool. So yeah, we have so there's going to be there's 43 samples that will be taking with us 5 are witness tubes. And the witness tubes are to help us analyze if there are any elements that are there on the surface of Mars, kind of contaminants that can be introduced from the rover or any other chemicals that we brought on from here Earth. And then we have about the other 38 samples that we'll be using to kind of collect the samples and hopefully bring back. But we're only going to be bringing back hopefully at least 20 samples, but we're hoping for 30 samples, which we are gonna designate to 3 different locations. So hopefully bring 30, 10 of each location. And so here you can see this video shows kind of a really slow motion of us collecting the sample. So on the turret of, there's the drill and core bits that will be going and analyzing on to the surface right there. And they'll be drilling through. And then once it's drilled through, the turret, the arm will go into the sample capturing system, and then will rotate from the horizontal position to the vertical position. And here underneath is we have what we call the SHA. It's SHA, which is the sample handling arm. And this is kind of what I was talking about. There's another arm on the rover, really complex system, which will take the sample into the analyzing system, which will see if the sample is worth collecting. And so once we successfully say, yes, okay, we're gonna take the sample, then we seal it and we move it into the storage units, which then later we'll use, and this is where we'll be dropping off the samples from. And as I mentioned, yeah, we're hoping to at least bring back 20 samples, but I think the main mission would be to do 30 altogether. So here we have Meta, which is actually, this is kind of like this is a cool one because so this is the kind of like weathering sensors that like will be used to kind of measure wind speed, direction, also radiation, dust, temperature, humidity. And the origin of this one's actually, I think you guys will like this one. This one was made by either a company or an organization in Spain, which this one kind of stands for. It's a Spanish translation for "me da," like "give me." So it kind of stands for, like, give me the weather, dust, radiation reports on Mars. So this one's a pretty cool one. This one, along with the other ones that I'll show you right now, it's kind of the these systems are which we'll be using for humans to Mars, which will help us kind of study the weather and everything that we'll need to understand more before going there. So MEDA, along with MOXIE. MOXIE is our carbon dioxide to oxygen converter. We'll be studying and seeing if we can convert carbon dioxide on the surface of Mars into oxygen, which won't only just help us use the oxygen to breathe on the surface of Mars, but we'll also be able to use that as propellant. You know, in rockets, we use liquid propellants. So with this, we'll be able to kind of take the carbon dioxide on the surface of Mars, create that into propellant, and be able to launch back to Earth, which that's kind of the hope. Once we do send humans to Mars, we do hope to bring them back we don't just want them to stay there. And also, yeah, it's like a 2-year mission. So going there, waiting for 2 years and having to come back, you need quite a bit of oxygen. So Moxie is actually inside the rover, and we'll be doing periodic capturing of carbon dioxide, converting it into oxygen. It's supposed to be about 1 hour each, like each, I guess, operation. And yeah, it's going to be really cool. And alongside Moxie, that will help, study also for future Mars exploration. We have what some people forget. We have a helicopter going to the surface of Mars, which is really, really cool. It's going to be really exciting to see and study to see if we can actually fly on a surface of Mars, this will be the first time we'll be able to do the first robotic flights on on Mars. So the surface of Mars has that 1% density of that of Earth's atmosphere. So being able to see if we can fly on Mars, it's going to be really exciting, and hopefully in the future we'll be able to send more, if not a larger, like rotorcraft there, and be able to kind of explore more. So this will help us also, this will help the Perseverance rover navigate of where to go. The engineer, so this helicopter is called Ingenuity, and Ingenuity is meant to fly from anywhere from 3 to 5 meters up high, and then anywhere from, I believe it's, I think, up to 300 meters in distance. And yeah, so this one is solar powered, and this will help us understand kind of how Mars atmosphere acts and reacts with our blades speeding up. So this is supposed to be at 24 RPM speed, and these wings are actually these blades are actually 4 feet long, which is pretty big for a helicopter. So it has two rotor blades that spin in counter directions. So this kind of is really, to its name, Ingenuity, is really ingenious, which coming back from like a regular helicopter, which has just one blade, trying to shrink that down and match the lift speed or lift of getting a little system up high is kind of really, really tough. So it's, to its name, it's really cool how they named it. And so Ingenuity will be on the belly of the Mars Perseverance rover. And so once Perseverance rover lands, Ingenuity will be dropped off, and then Curiosity rover will like move away. Will rove away about 100 meters, and then Ingenuity is not. It's going to be. So Ingenuity won't be operated until, I think, spring 2021, and then that's when it'll begin its full operations. So landing on Mars is not an easy thing to do. It's actually pretty challenging, but one of the new technologies that we have on the Perseverance rover is the terrain relative navigation system, which uses AI technology to help navigate the Perseverance rover onto the surface of Mars. As you can see, this image right here shows kind of the descent stage coming down and kind of like navigating itself and being able to be aware of all the hazardous environments. And so coming onto the surface, you want to be able to land somewhere safely. And what we didn't have before in Curiosity mission was this. So when we selected a landing site, we kind of selected a site, and once you have your operations already set there, there's no way of you controlling if you need to move out of the way of anything. But with this system, it's autonomous and be able to navigate away from any hazardous environments. So this has helped us increase, or I guess decrease the landing site and be able to land where we wanted to, and safely. So as kind of like the Curiosity rover also had was the entry descent landing phase, which is if you ever get a chance to look up the 7 minutes of terror video. And so this will show you 7 minutes of the Curiosity rover from hitting the atmosphere to landing on the surface of Mars. It takes about 7 minutes, and getting the message relayed back to Earth in the round trip, it takes 14 minutes. So by that time that the rover has entered the atmosphere, it's already back here on Earth. It's already either landed or crashed. Hopefully landed. So just like the Curiosity rover, we have the entry descent landing system that we are using, kind of like similar to that, since it's been proven to be successful. So we'll be coming in from about 13,000 miles per hour and eventually shooting the parachute to slow us down, and then using the descent stage powered by the rockets to help us slow down and slowly slowly lower the rover onto the surface using these three bridle cables. And so as you can see, there's a fourth cable, and that's actually a communication cable that helps us still communicate with the rover until it has landed. And as soon as it has landed, it'll cut those cords using like pyrotechnic shocks, and then the descent stage will shoot off and blast away safely. And then once that's all done, we are ready to begin our operations. So the Perseverance rover has a full itinerary. From beginning to end, it's going to be using and operating its systems. The interesting thing is, we can't just use all the instruments and systems and everything that's on the rover all at once. So it's kind of coordinated to be a scheduled delivery of, okay, when are we going to be using the arm, whenever you're going to be using the Moxie instrument, whenever you're going to be using the other instruments. And it's a team effort. But ultimately, yeah, once we have landed in February 18th, 2021, it's gonna be really exciting, and hopefully we'll eventually be able to answer the question is if there is life on Mars. So I have a quick video for you guys to show you. So yeah, so this video was taken December 2019, and this was the Perseverance rover's first steps. And so this was done at JPL in the spacecraft assembly facility. And so this, you can see the rover is a little bit sped up as just for use for testing. And so going on the incline on this little ramp, you can see the actual suspension system, the rocker bogie system, having the wheel in the front and then the two in the back. So you're actually able to use this rocker bogie system to go up to incline of 30 degrees, and if also up to 45 degrees incline without any trouble. And so people like to ask, what's the actual speed of the rover? Well, it's about 0.1 miles per hour, which I think is 4.2 centimeters per second. Yeah, but on the surface of Mars, we don't really need to go too fast as the operations. There's no really need to go any faster than this. We're able to go up to, I believe, 100 meters a day, and since it's fully autonomous, there's really no need for us to be driving this single-handedly with the joystick. So yeah, this was a really exciting day to be able to see the rover, finally take its first steps. And also at the same time, while we were doing this, we were also testing the RIMFAX system in the back, taking data of the ground. So yeah, that's kind of all I have for you today, kind of an overview of the Perseverance rover and a little bit of what I do. here at JPL. And as I mentioned, yeah, if you go here, the mars.nasa.gov/Mars 2020, that's where you can find pretty much all the information of the Perseverance rover. And as well as you can see where it's at right now, located in space. So that's really, really cool to see. But yeah, so thank you very much. I guess I'll bring it back to Wilbert's.
Thank you, El, for that very informative talk. Very cool also. I loved it. And I'm sure that people here also love your talk and learning about Mars and Mars Perseverance.
Yeah.
Um, so as I said, guys, if you have questions, please write them down in the chat. I have some of mine and I'll begin with those and I'll give you some time to write down yours. Um, as this is for Leo regarding his career. You're an early career fellow at JPL, and I was wondering if you had any advice for people like us, undergraduate students that are looking to go into the industry, particularly NASA and more specifically JPL. How should we, follow that dream or goal? And if you have any recommendations for skills that people at NASA are looking for in their new recruits.
Yeah, so I mean, the main thing is just to search online and apply. First and foremost, just if you ever see any opportunities out there and you see that you qualify or are kind of aligned with what you're doing or what you want to do, just either if you can apply or look at those requirements and see if that's something that you can, acquire or study. The second thing I would say is get involved. I think getting involved is really, really important. If it's not just, like if you get involved in a student organization or some sort of engineering organization at your school or elsewhere, get involved as much as possible, especially if it's something you're interested in. If it piques your curiosity and it's something that you're really passionate about, just get involved as much as possible, learn as much as possible. At NASA, there's so many different, opportunities and so many different types of careers and positions and roles. But the main thing, if you are from an engineering background, I would say just get an engineering degree. In the end, it kind of, not that it doesn't matter, but like you could come from a mechanical engineer background, a aerospace background, chemical engineer, civil engineer. As long as you have that degree, it kind of opens those doors for you to be able to get admitted. And there are a lot of internship opportunities, I know, for foreign and like non-foreign folks to come to JPL. So I was looking online, and yeah, some of them don't have any restrictions if you are a citizen of the US or not. So I think just applying and kind of just getting involved in any way, shape, or form. Kind of how, okay, so kind of how I got in or got selected, or I guess how they kind of like brought me on to JPL is my boss, who I interviewed with. He kind of mentioned that he saw that I was doing a lot of extracurricular activities, like a lot of things that I was getting involved in that were Mars related. So that kind of like piqued his interest, and so eventually he wanted to kind of talk, like sit down and talk to me. And because I was involved in the Mars Society, I was also involved with the Planetary Society, and right now I'm currently involved with Spaceport LA, kind of helping them. And yeah, this is just as much as possible, become a member of the AIAA, the Mechanical Engineering Society, just as much as possible, just get involved and yeah, just kind of see what you can do.
Perfect. I have another question. We know that you guys are working sometimes virtually, sometimes on site. But what is everyday life at JPL, like working at JPL?
Oh, okay. Is this pre-COVID or?
Yeah.
So yeah, working every day at JPL it's fascinating. It's you feel the energy there. People walking around. You get to or you're able to kind of just sit down and chat with, you know, the smartest people and the brightest people. And it's really, really cool to be able to see what everyone's working on. You know, you're able to go into these buildings that they're testing new technology. They're testing the rover, you know, testing these other satellites or spacecrafts that we have being built there. Yeah, it's exciting because everyone there is just, you know, they're there for the same reason as you are, and so you're able to easily connect with them. And yeah, being able to, well, yeah, pre-COVID, when you're able to kind of walk around and just talk to anybody, have coffee with, you know, the chief engineer of this program and that program, and kind of pick their brain, it's kind of nowhere else on earth that I can think of or that I've been to that you've been able to do that.
Perfect. I have a question from Alanis Matias, and she says,
Mhm.
"What has been the biggest challenge in your career?"
Hmm. Biggest challenge in my career, I would say it's kind of I think a challenge that other people have had too. It's kind of the imposter syndrome, where sometimes you don't feel or think or yeah, or like you don't feel like you belong somewhere, because you either think you're not smart enough or not good enough. But in the end, you know, it's something that you're there for a reason, and you're there because someone believes that you have the capabilities, and you have the understanding to be there. And so that's kind of been the kind of a challenge, and it's kind of more of an internal challenge of like you're thinking that you're not good enough for something, but you know, like you really are. You're kind of battling yourself. But as for an actual like engineering problem, you kind of the coolest thing about working, you know, at JPL is that you're always learning, and it's never like there is never a dumb answer or a dumb question. So they always kind of they want you to ask questions, you know, because you that's the one thing that like it's going to help you, if not now, in the future. Just, you know, ask questions. But yeah.
Perfect. Um, I'm not seeing any other questions in the chat, but I have a question regarding the wheels. There's a difference between the wheels of the Curiosity rover and the Perseverance rover, particularly the tread design. On Curiosity, you have like a chevron design, and then on Perseverance, you have like a more like curvy design. Can you explain what the curvy design is for?
Yeah, so the curvy designs, the Gausser design is primarily for to increase the kind of the traction of the wheels, so it won't slip. And also, as I mentioned, the Curiosity rover, the chevron design actually had issues with the stress inside of, right in the middle of it. It started to crack over time. So the new design kind of allows that to be kind of like eliminated. And so it's that this new design not only just helps it with the traction, but also from the stress as well.
Perfect. Let's see if anybody else has questions. Um,
Yeah.
so I have a question here. It comes from somebody that I don't have his name or her name,
Mhm.
but uh, that person says that uh, they want to become an aerospace engineer. And what type of internship do you recommend to apply to?
Oh, in the aerospace engineering field, there's so many different types of internships you can apply. It kind of just depends on what you're interested in. Is it going to be aircraft, spacecrafts, or and also depending on the I guess the company or uh, what type of mechanisms you want to kind of work on. There's just so many different places that kind of offer that. So I don't really have a specific answer for that one, but yeah, whatever company kind of piques your interest, and or if you want to do a rocket company as well. As an aerospace engineer, there are, you know, a limitless amount of opportunities. especially nowadays. There's so many different space companies and yes, like rocket companies too, also kind of coming out.
Now, Leo and I were talking about his current project at JPL in the pre-show, and I just wanted you to explain a little bit about what DSOC is and what you guys are doing with the Psyche mission.
Oh yeah, so currently I'm working on a program called DSOC, which is DSOC, which is a Deep Space Optical Communications. And so what DSOC is, it's going to be using or studying to use laser communication versus the regular bandwidth communication that we're using now to increase the speed of communication in deep space. So essentially, we're launching on the with the Psyche mission. It's not part of the Psyche mission itself, but ours is a tech demonstration. And Psyche mission is launching to an asteroid called the 16 Psyche. And so what DSOC is going to do is going to be studying the laser communications on its way to that asteroid, which is going to be passing Mars and into deep space. So eventually we'll be able to communicate back to Earth faster than we do now, with the hopes of increasing that communication for future missions to Mars and also for human exploration to Mars.
Perfect. Now, back to questions regarding your career. As you said, you have been at JPL for 2 years now, but where do you envision yourself within JPL from, let's say, here to 10 or 15 years from now? Like in what position or doing what type of work at JPL or somewhere else?
Yeah, so this is a kind of an ongoing question I always have for myself. I think right now as a manufacturing engineer, it's kind of be a stepping stone into what I want to eventually become a systems engineer. That's kind of my next goal, at least at JPL, to be part of either the next mission to Mars or another mission that's outside of our planet, maybe the next mission to Venus, which is still in proposal. But yeah, as for me, it'll be kind of a systems engineer role, being part of kind of like overseeing many different kind of systems and different operations, from anywhere from the design to testing, as well as the kind of the other side of things where I deal with kind of like analyzing data. And then from there, I kind of just like to see where that takes me, so kind of a step-by-step process. We'll see. I think your microphone's off.
Oh yeah, I was saying that, yeah, thank you for that answer. At the moment, I'm not seeing any other questions on the chat or other social media, but I just wanted to know if you have any other, let's say, advice or parting words for the audience tonight.
Yeah, so like the thing I like to always kind of point out is if you have a dream or a goal or something that you're passionate about, always chase after that, no matter what anybody tells you, especially if it's something that you really, really, really want to do. Nowadays, there's so much resource out there, and there's so many people that you can talk to and reach out to. And yeah, it's just always just follow your dreams. Kind of like one thing I didn't really understand until later in my career was that whatever opportunity is there for you, take it. And at this point, and like anything really is possible. And I didn't think that I had the, I guess, the knowledge or the so the knowledge to work at JPL. But then meeting people and knowing people that have worked there or are working there, it kind of gave me that inspiration to chase after that dream. And so, yeah, I guess I'm one of those testament of, if you follow your dreams, stick to it, and just keep, working at it. No matter what, you will get to where you want to be.
Well, that's a wonderful answer. It's an advice that I myself will take, and I'm pretty sure that people watching this will also, live by that, live by those words. And with that, we conclude tonight's Space Talk by Leonard Ortiz from NASA JPL. We want to thank him for taking some of his time to talk to us. Especially during these times of pandemic. Uh, and thank you, the audience tonight in Zoom and in those that are watching this in the future. And just stick around for other space talks by SEDS-UPRM and other initiatives that we will have during this semester. And to Leo, thank you and good night. Thank you
Gracias a
for being
todos. Gracias.
here.